Good afternoon, everybody. I'll present to you some trophic relationship or some aspect of trophic relationship of hake and shark. I'm not a shark expert. I work for the Ministry of Fisheries, and I'm more involved with hake studies, biomass assessment of hake and all that. But this is part of my PhD, one of the sections of my PhD study that I'm doing with Rhodes University and supervised by Nicole. And I'm trying to use stable isotopes so that to get some inferences on the trophic relationship of the two species. The reason that I'm doing it is that because these two, the hake and shark, they do have depth. The three species that I'll look at, they do have depth, overlapping depth distributions. When you do survey, we catch them, and we catch them at station where you mostly catch, where we are also catching hake. And some stomach-coated studies that have been done previously on shark indicated that shark eat hake, and stomach-coated studies that have been done on hake also indicate that some of the hake prey are also common with they have common prey with shark. So the main research questions that I had in mind is just how trophically related are they based on the isotope signatures. So that means I have to go out, collect tissues from Hake, the three shark species of Namibia. And the isotopic analysis was only focused on the two isotopes, the carbon-13 and nitrogen-15. And what you get from carbon-13 is mostly the source of production, and while the nitrogen-15 gives you an indication of the relative trophic position of that species. So the isotopic measurements that I got, I put them through this analysis or this test. The first one was just an ANOVA with HSD post-hoc test, just to look at if there is a significant difference between their values, and also to do a pairwise comparisons. And then I used another method, SIBA, which was published in 2011. What this method does, it's mostly comparing trophic niches of different organisms. And the advantage of this method is that commonly in stable isotope studies, we are comparing so many organisms with different sample sizes. And this one is more, it's not that independent, but it's less affected by the sample sizes. So you will be able to compare organisms with different sample sizes. And then I used SIAS. This is just one of the isotope mixing models that is also been published in 2010. The basic idea behind this is just that one can be able to have an idea of physical contributions of a certain source into the stable isotope measurements or values of a predator. So I've used it to look at the contribution of hake in the diet of the three shark species, and also the contribution of other prey in the diet of sharks. This is just isotopic characteristics, just a summarization of the data that I have. A number of hake and a number of sharks, and this is the trophic position calculated based on the nitrogen-15. And what you can see is that most of the sharks have higher trophic position than hake species. But one of the weaknesses of stable isotope is that trophic position, it is calculated based on the assumed trophic enrichment factor, which differ from species. If you don't have a species-specific trophic enrichment factor, that basically means that you use the commonly used one that are not specific to your species. So this is just an idea. It might not be until we get species-specific trophic enrichment factors for hake. These are just based on the assumption of the commonly used enrichment factors. The ANOVA results. This is just the pairwise comparison of the carbon or nitrogen-15 of different species. What we have here is, for example, DC is Deania calcea with Centrophorus squamosus. Then you have DF Deania profundorum, MC, that's M capensis, one of the Hake species, and P, M paradoxus, Hake species too, and then you have yeah, it's just a pairwise comparison of those species. And on what you have here, it's a mean differences, and if the mean differences with this confidence interval does not touch this line, which is 0, that means that the pairwise comparison of those two species are significantly different from 0, which means they are significantly different from each other, significantly different from each other. And in terms of the nitrogen 15, we know what I saw is that the two sharks from the Deania genus, they are not statistically different from each other in terms of 15. That basically means that they probably consume species or prey from a different, or from the same similar trophic position. And then you have paradoxus, one of the Hake species, and Deania calcea, one of the shark species, that are also not trophically different from each other. This is what I didn't expect, because I know sharks are supposed to be top predators, and now I'm seeing that it depends on the species. There are some sharks that are so different from Hake, but paradoxus that is not trophically different from Deania calcea, but then the two Hake species are also not statistically different from each other, which is not surprising, because I had a paper published last year that looked at the tongenic trophic shift of the two Hake species, and it also showed that they are not significantly different from each other. And then in terms of delta or carbon 15, which look at the source of production, here it seems that all the species were not statistically different or statistically significantly different from each other, which basically means that most of them do consume and prey from the similar source of carbon. But the only difference was paradoxus, one of the Hake species, and squamosus, one of the shark species. They were completely different from each other, and this might mean that because paradoxus it might mean that paradoxus have a diet, although it mixes diet from both the benthic sources and the pelagic source. The diet is more dominated by these the pelagic species. While the shark species, although it does mix, it can mix both sources from both pelagic and benthic. Its diet is more dominated by prey from the benthic sources, and this is the only difference. Otherwise, all the other species, pairwise comparison, were not significantly different from each other, and that means they mix both the sources. And the SIBA result, which is comparing the niches of the species that I have. This is what you say. This dotted line here, this is when you are just plotting isotopes without using SIBA, just having a convex hull of the isotopes. And this is what the SIBA program is trying to avoid, because this convex hull changes with sizes. So if you add another sample there, it will be a different convex hull too. So SIBA tries to avoid that, and this is they say, or according to those guys that published it, they say it's independent or more robust against size. And what you can see here is that the black circle is squamosus. It seems to be the only species that is different from all the other species. It does not overlap with any of the species. But why the other two sharks from Deania genus, they both have an overlapping niche with both paradoxus and capensis, the two Hake species. And then in terms of niche sizes, it's just the size of that circles. It looks like paradoxus is one of the smallest niche sizes, which is significantly different from capensis. And this is quite surprising, because they are not, according to the 15 nitrogen 15, they are not trophically that different. But then it says here, according to their niche size, their paradoxus one is significantly smaller than the capensis. But otherwise, the shark species they don't have significant different niche sizes. And the SEA results, the contribution of different preys in the diet of sharks, starting with the CES, the Centrophorus squamosus. I used a number of preys, isotope value, just to look at, to learn them together with the Hake data that I have. What you can see here is that for this species, there seems to be an increased contribution of crustaceans, while the Hake species, they are not that much. They, according to the raw result that I have, they are about 5%. Their contribution is about 5% into the diet of this. The next species, and the contribution of different species does not look to be so much different. That means it probably feed on the variety of prey, and it's probably an opportunistic species too. It depends on the availability of the prey. And the same applies to this Deania, or the another Deania profundorums, which it looks to have a similar dietary contribution of different species than the Deania calcea. So the conclusion, the preliminary conclusion that I got from this is that the Hake species and the some shark species, they do have overlapping trophic niche. So and also that one of the Hake of shark species seems to have a weak dialectic trophic interaction with Hake species, and it also looks to have, or it does have different carbon sources if you compare it to M. paradoxus, one of the Hake species, but it's not also it's not its carbon source is not significantly different from the M. capensis, and there is also increased contributions of crustaceans in the diet of squamosus. And I think those are the primary or preliminary conclusion that I can have. I just and that was my presentation. I just want to thank this was the ministry, my employer. They paid for the ship time. The Rhodes University paid for my trip here. And there is a project within the Beguera Current Commission, which is a commission between Namibia, Angola, and South Africa, that look at the trophodynamic of the major commercial species, and it did fund the isotopic analysis of the samples that I used. Thank you.